Welcome back, everyone. Welcome to the Internship Studios session on high availability and scaling in AWS. So, we'll see what are the scaling and availability options and accordingly see the services as well. Actually, these availability and scaling is very much required for applications that are global in nature. So, they have a wide global audience and global usage of customers is there, and they require to fulfill the requests globally. So for this, I think their applications must be always available. Available in the sense always be up for the customers when they need. So and there must be no downtime or any critical downtimes for customers. For example, mostly these banking or high-tech financial applications, they need this kind of technology to power them to be always available. Scaling means to scale up or down. So, for example, based on the need, the infrastructure can be maximized and minimized. So, in terms of cloud, we need to first ask what is high availability and scaling in cloud. So, first, the definition of high availability is it refers to the ability of a system or application to remain operational and accessible for users even in the face of hardware failures, software errors, or other disruptions. So the primary goal of high availability is to minimize downtime and ensure continuous service availability, thereby improving the reliability and resilience of the system. So first we need to understand high availability. So imagine you are hosting a grand event, let's say a music festival, and you want to ensure that the show goes on seamlessly without any disruptions. So high availability in the cloud can be likened to the meticulous planning and backup systems you put in place to guarantee that the festival runs smoothly, regardless of any unforeseen challenges. So in cloud computing world, high availability refers to ability of a system or application to remain operational and accessible for users even in the face of potential failures or disruptions. So it's all about minimizing downtime and ensuring that services are consistently available. So now again let's delve into the analogy more. So you can imagine multiple stages as regions. So we have different stages for different singers. So they can be like there are some different stages, right? So they can be correlated with AWS regions. So in the festival analogy, consider each stage as a region in the cloud. So you decide to have multiple stages spread across different areas to cater to a larger audience and to reduce the risk of a single point of failure. Similarly, cloud products like AWS, what they do offer multiple regions worldwide. For example, we may have a region in Mumbai in India and another region in some Toronto in Canada or another region in Frankfurt in Germany. So distributing your resources across these regions ensures that even if one region experiences issues, for example like bad weather affecting a stage, other regions can pick up the slack. Also, we already seen load balancers, right? So load balancer we can tell that as festival organizers. So festival organizers play a very crucial role in ensuring that attendees are evenly distributed among the stages, preventing overcrowding in one area and leaving others deserted. So in the cloud, load balancers serve a similar purpose. So they distribute incoming network traffic across multiple servers to ensure no single server bears too much load. So this optimizes resource utilization and hence enhance the system reliability. Next we can take up redundancy. So imagine having backup performers ready to step in if the main act encounters unexpected challenges. So similarly in the cloud, Redundancy involves having duplicate resources and data backups. For example, some data like snapshots can be backed up. So if one server or data center fails, another can seamlessly take over, preventing disruptions. So this redundancy extends to various levels such as hardware, networking components, and even entire data centers. So we can also consider fault tolerance as weatherproofing. So we have heard this word a lot many times now. So just as outdoor events need to be weatherproof to withstand unexpected rain or storms, cloud systems must be fault tolerant. So this means designing applications and infrastructure to continue functioning even if one or more components fail. So techniques like data replication and automatic failure mechanisms ensure that show goes on even when we faced with unexpected challenges. So scalability is the next word that we saw. So scalability we can consider as ticket flexibility. So suppose your festival gains unexpected popularity and more attendees want to join. So scalability what it does, it allows you to quickly adapt to changing demands, just like selling additional tickets or expanding venue capacity. So in the cloud, auto scaling features enable resources to dynamically adjust based on the workload. So this ensures optimal performance during peak times and cost savings during quieter periods. Also, monitoring automation is also there. So we can consider that as event management. So festival organizers employ a vigilant team to monitor the event, ensuring everything runs smoothly. So similarly in the cloud, robust monitoring tools and automation scripts continuously check the health of systems. If an issue arises, automated systems can quickly address the problem, minimizing human intervention and reducing the downtime. So, in conclusion, we can say high availability in the cloud is akin to orchestrating a flawless music festival. So, by strategic planning, distributing resources, implementing redundancy, and automating responses, cloud systems ensure a continuous and reliable experience for users, just like successful and uninterrupted music festival. So going to the next slide. First is the strategies. So what it will help us do first is the redundancy. So deploying redundant components or systems to take over in case of failure. So this we already discussed. Next is the load balancing. Again it will help us in distributing incoming traffic across multiple servers to ensure no single server is overloaded. Next we have the failure systems. Automatic switching to backup systems or resources when a failure is detected. For example, backup we may have snapshots or some in case of Kubernetes environment we may have EKS clusters set up in multiple regions. So if the application is running on Kubernetes, then we can quickly shift between the clusters of different region. So next we have the geographic distribution. So spreading resources across multiple data centers or regions to mitigate the impact of regional outages. So since there are multiple data centers available within the AWS, so you can cleverly design our architecture such that no two data centers are in a single region within like two availability zones. So this is regarding the strategies. Next is the scaling. So we'll see the official definition of scaling like a generic one. So scaling in the cloud context refers to the ability to adjust the resources allocated to an application or service based on changing demands, whether it be an increase or decrease in workload. So the goal is here is the primary goal of scaling is to ensure that the system can handle varying levels of load efficiently, maintaining performance and responsiveness. Next, we usually have the types of scaling. We have the vertical scaling means scaling up, which means increasing the capacity of a single server by adding more resources. So we have the components like CPU, RAM, storage to handle increased load. Next we have the horizontal scaling, which is scaling horizontally or outwards you can say. Adding more servers to a system to distribute the load and accommodate increased demand. So this is an overview of scaling. Also, we'll see a comparable analogy here again. So let's explore this concept using that of a restaurant. So that experiences varying customer demand throughout the day. Scaling in the cloud is analogous to how the restaurant adjusts its capacity and resources to efficiently handle fluctuating number of customers. So we may first see restaurant capacity as initial resources. So imagine opening a restaurant with a fixed number of tables and staff to accommodate a certain number of customers comfortably. So in the cloud, this initial setup is akin to provisioning a set specific amount of computing resources like servers and storage to handle the anticipated workload. So we normally see lunch rush as peak workload. For example, in restaurants we have this lunch rush around 1 to 3 p.m., right? That's usually the lunch timing. So similarly to a restaurant facing a lunch rush, businesses might experience spikes in demand for their services as well. For example, during sales in any e-commerce applications like Flipkart, we may see like during the months of September, October, we may see huge demand. So scaling in the cloud allows you to handle these peak workloads effectively. So during the lunch rush, the restaurant might call in extra staff or open up additional seating areas. So in the cloud, this is achieved through horizontal or vertical scaling. So horizontal scaling in the sense it is like opening more branches. So when the restaurant realizes it needs to serve more customers, opening additional branches is a form of horizontal scaling. For example, one main branch is there in city A, so open a branch in city B, open a branch C in city C. So like that you keep on adding more restaurants. So in the cloud, this means adding more virtual servers or instances. Instance means easy to instances to distribute the load. So it's like replicating the restaurant setup in different locations to accommodate more diners simultaneously. Because at a time, like if like at the same time, people can dine in two restaurants in two different cities. So that's how like it's accommodating at a time simultaneously. But vertical scaling is like hiring more staff. Alternately, like if the restaurant decides to increase the efficiency of its existing location by hiring more staff, this is similar to vertical scaling in the cloud. So vertical scaling involves adding more resources to a single server, making it more powerful and capable of handling increased demand. It's like adding more waiters to a restaurant. So if you have one hotel, so there are some 50 waiters catering to 100 people. So you can see that if there are 200 people, then you add up 50 more waiters. So total becomes 100 waiters to 200 customers. So it's like that, just adding in that one point. Next, we also have this dynamic scaling options as well. So dynamic scaling, imagine the restaurant dynamically adjusting staff levels based on time of day or special events. So similarly, dynamic scaling in the cloud involves automatically adjusting resources based on real-time demand. So when there's a surge in users or transactions, the system scales up, and during quieter periods, it scales down to save costs. Also, we have a load balancing as usual. So in a busy restaurant, you can see the manager strategically assigns customers to available tables. So similarly, load balancing in cloud serves a similar purpose by distributing incoming traffic across multiple servers to optimize resource utilization. So cost efficiency also is a thing. So restaurants aim to minimize waste by managing the food inventory very effectively. So similarly in the cloud, what happens? Scaling allows businesses to optimize costs by not only using resources they need during off-peak hours, for example, when there is not much demand, the cloud infrastructure can automatically scale down during like non-festival days. So it reduces costs associated with unused capacity. Also, there is automation here as well. So think of a restaurant with automated kitchen equipment that adjusts cooking times and temperatures based on the order load. So in the cloud, automation tools help streamline scaling processes Auto scaling features can automatically add or remove resources based on predefined rules, ensuring optimal performance and cost efficiency as well. So how this high availability and scaling relate? So this is the question. So availability and scaling are often interconnected. So achieving high availability may involve the use of scaling strategies to distribute load and provide redundancy. Scalability is essential for maintaining high availability, especially in dynamic environments where workflow fluctuations are common. Cloud providers offer tools and services to facilitate both high availability and scaling, allowing users to design resilient and scalable architectures. So these are both faces of the same coin. They actually go hand in hand. So how we can say, how we can put together in a single sentence? I can use the sentence. So high available systems are always scalable, and all scalable systems are highly available. So this is kind of, we can say, a rhyme that we can say. So this is how they both relate. They are both faces of the same coin of the cloud. Next, we should see the benefits of high availability in cloud and AWS. One is improved the reliability and uptime for critical applications. Second thing is reduce the risk of data loss or service disruption. Next is enhanced user experience and customer satisfaction. So again, like as discussed, increased reliability is always an awesome feature here. So high availability ensures, for example, we can take the application of Flipkart here. So high availability ensures that Flipkart application is consistently accessible to users. So in the cloud, redundant systems and failure mechanisms are implemented to minimize the downtime. So this reliability is actually very crucial for e-commerce platform like Flipkart. So where users expect 24 by 7 by 365 access to browse products and make purchases. Also, there's a enhanced customer satisfaction as well. So uninterrupted access to Flipkart application, it always leads to higher customer satisfaction and it brings a smile on your face. It will give you confidence that I'll buy something today. So users can buy, shop and complete transactions without disruptions, creating a very positive and reliable experience. So what this reliability does is it builds trust among the customers, encouraging them to use the platform for their shopping needs. Next is it also fosters the business continuity. So high availability ensures business continuity for Flipkart. So even if one part of the infrastructure experience issues, other redundant systems can seamlessly take over. So this resilience safeguards against potential revenue loss for them and also for its stakeholders and maintains the overall functionality of the application. So there's also mitigation of the downtime costs as well. So downtime can be very costly for e-commerce applications. Downtime normally we can say outage. So if the application is out, so it results in very huge revenue loss and potential damage to the brand reputation as well. So high availability strategies in the cloud minimize downtime here. So reducing the financial impact of service interruptions. Flipkart can maintain continuous operations during peak shopping periods, such as some sale events, for example, the big billion day events, without risking any outages. Also, cloud, what it does is through high availability, it allows Flipkart to scale its resources dynamically based on user demand as well. So, during peak shopping seasons or special promotions, the application can quickly and automatically scale up to handle the increased traffic. So, the scalability ensures that users experience consistent performance even during the high traffic periods. Also, we know that Flipkart likely serves a global user base, so there are customers across the world. So, high availability in the cloud enables the distribution of resources across these multiple regions in the world. So, users from different geographic locations, for example, like Bangladesh, Sri Lanka, or any, I think it's banned in China, but yeah, it's available across some other Singapore, for example. It can access the application with low latency, providing a seamless experience regardless of their location. Next is fault tolerance as well. So cloud-based high availability ensures fault tolerance within the Flipkart application. So if a server or component fails, redundant systems can take over without affecting user experience. So this resilience is very crucial for preventing service disruptions. We have the load balancing as well, which is world class by AWS. Also, high availability strategies these often involve this data replication and backup systems. So in the event of a data loss or security incident, Flipkart can recover quickly and ensure that user data is protected at all times, because it will actually there are some compliance issues like the payment cards data compliance, which is one of the important compliance of the cloud industry. So this aspect is crucial for maintaining user trust and complying with data protection regulations. Next, we have the adaptability to market changes. So the e-commerce landscape is very dynamic nowadays, with market trends and user behaviors evolving in a day-to-day basis, as we can see. So high availability in the cloud allows Flipkart to adapt to these changes very seamlessly, whether it's handling a sudden influx of users or implementing new features. So the platform remains very agile and responsive, we can say. So there are a couple of strategies for achieving high availability in AWS. The first thing is implementing redundancy across multiple availability zones. So we can leverage the concept of deploying resources to multiple availability zones instead of single, to see that it's always fault tolerant, the application. Next is we may leverage load balancers for distributing traffic and preventing single point of failure. So load balancers are an awesome feature. Actually, they are the core components of the networking of the infrastructure. So they will distribute traffic uh, very nicely and prevent a single point of failure. So if there is only one thing that is pointing towards in the back end, then it's very problematic for the load balancer, because the whole application will go down. So this is how load balancing works. So AWS obviously has the world-class global load balancing feature with its variety of load balancers like application load balancer, network load balancer, and cross-zone load balancer as well. Next, we have the leveraging of auto scaling to dynamically adjust resources based on demand. So AWS has something kind of auto scaling. Auto means like the pilot mode in cars we have, right? Nowadays, I think Tesla had some pilot autopilot mode where it can steer itself on the road. So similarly, AWS has launched something called as auto scaling. So based on the demand, the resources will scale up and down accordingly. So if the demand is very low, it will accordingly provision the resources for low numbers. If the demand is high, accordingly it will scale up based on the demand. These are couple of strategies. Next is the redundancy in high availability architecture. So how to achieve this using a HA architecture? So first thing is replicating data across multiple instances or regions. So actually redundancy is very vital for data integrity and availability as well. So data is often replicated across multiple storage systems or geographically distributed data centers. So this ensures that even if one copy of the data becomes inaccessible due to hardware failure or other issues, there are redundant copies available for retrieval. So next is like using multiple servers to ensure continuous service availability. So in a high availability architecture, redundant servers are deployed to ensure that if one server fails, another can take over the workload. So load balancers distribute incoming traffic across these redundant servers, optimizing resource utilization and preventing any single server from becoming a bottleneck. So application redundancy is also one of the feature here. So redundancy is implemented on the application level by deploying the duplicate instances of critical applications. So if one instance experiences issues, traffic can be directed to another, maintaining service continuity. This is often achieved through techniques like clustering. So, employing backup and recovery mechanisms for system resilience. So, redundancy is most effective when coupled with automated failure mechanisms. So, in the event of a failure, whether at the server or application level, automated systems detect the issue and they redirect traffic to the redundant healthy components without requiring manual intervention. So, this minimizes downtime and ensures quick recovery. To ensure the effectiveness and of redundancy in a high level architecture, regular testing and maintenance are very crucial. So this includes stimulated failure scenarios where we actually in the modern times they call chaos engineering and routine checks to ensure and address any potential issues before they impact the system. So this is about the redundancy. Next is load balancing for high availability in AWS. So it's the backbone of the whole application architecture in AWS. So it distributes incoming traffic across multiple instances or availability zones. So it prevents overload on individual servers and improves fault tolerance. It also supports scaling and ensures optimal resource utilization. As we saw in our load balancing session as well, AWS load balancers excel in seamlessly distributing incoming application traffic across multiple targets such as EC2 instances, maybe containers or IP addresses. So they have one of the most commendable aspects, which is ability to effortlessly scale horizontally to handle varying workloads. So as your application's demand grows, AWS load balancers dynamically adjust to the increased traffic, enabling your application to scale up or down with ease. So we have this application centric load balancer, which takes load balancing to a whole new level by offering advanced features for routing and content based routing. So these load balancers are defined with high availability and fault tolerance in mind from scratch. So by distributing traffic across multiple availability zones, these load balancers ensure that your application remains available and resilient even if a specific data center or region faces disruption. So one beautiful thing is it has integrated monitoring and logging capabilities as well. So you can easily track key performance metrics, gain insights into traffic patterns, and use this information to optimize your application's architecture for peak efficiency. So there are some adaptive load balancing algorithms which are employed by AWS which can be tailored to suit specific application needs. So whether you need a simple round robin approach for a more sophisticated algorithm based on factors like least outstanding requests or latency, AWS load balancers provide the flexibility to meet the requirements. Also, AWS load balancing seamlessly integrates with the auto scaling groups in AWS, so enabling automatic adjustments to handle the varying workloads. So, as demand increases or decreases, the auto scaling groups interact with the load balancer to dynamically add or remove instances, ensuring optimal resource utilization. So anyway, it's cost effective as well as we saw earlier. So it follows a pay as you go pricing model, allowing you to pay only for the resources you consume. So this cost effective approach combined with the ability to scale resources based on demand makes AWS load balancing an economical choice for businesses of all size. So next is auto scaling in AWS. So this is another good feature of AWS. So it automatically adjusts resources based on predefined scaling policies. So if you have set up any predefined policy, then the AWS will automatically adhere to it and follow the same. Next is scales up during periods of high demand and scales down during low demand. Also, it ensures efficient resource allocation and cost optimization. So the beauty of AWS autoscaling is it enables the automatic adjustment of compute resources based on real-time demand. So it dynamically scales the number of EC2 instances, allowing applications to seamlessly handle increases in traffic and efficiently scale down during periods of reduced demand. So it has a greater advantage of its integration actually. So the core of its beauty is its integration with all the AWS services, like most of the popular ones like EC2, Elastic Load Balancing, and CloudWatch. So this interoperability, what it does, it ensures a very holistic approach to the resource management, allowing auto scaling to respond effectively to varying conditions. It also supports something called as target tracking scaling policies. So where you can set a target value for a specific metric such as CPU utilization or request count. So the service then automatically adjusts the number of instances to meet the defined target. So optimizing resource utilization while ensuring performance goals are met. So it also leverages machine learning algorithms. So autoscaling offers something called as predictive scaling. So it will predict and anticipate changes in the demand. So by analyzing historical data and patterns, the service can proactively scale resources before the demand spikes, preventing performance degradation and ensuring a very smooth user experience. Next is also the scheduled scaling. So for applications with predictable workload changes, auto scaling provides scheduled scaling. So this feature allows you to plan ahead by defining specific times and dates when the capacity should be adjusted. So it's particularly useful for handling periodic increases in demand such as during sales events or marketing campaigns. So this auto scaling also facilitates something called as rolling updates. So it allows new instances to be gradually replaced while maintaining application availability. It also performs health checks on instances, ensuring that only healthy instances are added to the group and that any unhealthy instances are automatically replaced, guaranteeing the integrity of the overall system. So it also supports instance termination protection, so preventing instances from being prematurely terminated. So this protection ensures that the instances critical to ongoing tasks or processes, for example, any financial application that we have. So it should not be terminated midway, right? So this is taken care of by not inadvertently removed during scale down events, maintaining application stability. So another finally to get by, it's also designed to distribute instances across multiple availability zones for enhanced fault tolerance. So the multi-AZ deployment ensures high availability even in the face of data center failures or other unforeseen disruptions. So it makes a very robust solution for maintaining customer service. So businesses can achieve high cost efficiency by only paying for the resources they need here. So this service automatically adjusts the number of instances based on demand, minimizing over provisioning during the periods of low usage. So thereby what it does, it optimizes costs associated with infrastructure. So to put it, it says it provides a very comprehensive, automated and intelligent solution we can say for managing resources on the cloud. So this is how the high level infrastructure that is powering the AWS autoscaling. So when the users via the internet access the application, so based on the demand what it does, this CloudFront which is a content delivery service, there is the internet gateway. So elastic load balancing as we know it's already uh, global service by AWS, which is also has the provisioning of auto scaling. Next we have the Amazon EFS, which is Elastic File Systems, and we have this auto scaling groups. So we can add any type of resources into the auto scaling groups, for example, EC2 or RDS or database related instances. So if we enable auto scaling for the instances, then accordingly it will auto scale. So they have segregated, for example, for fault tolerance, one availability zone is in like one RDS DB instance is one availability zone in this VPC subnet. Again, in different VPC subnet, it is in different availability zone, and they have both paired this using the VPC pairing. So this is how the scaling works at a high level. So there are some couple of scaling options. So initially we have the vertical scaling by increasing the size or capacity of existing resources. We have the horizontal scaling by adding more instances or service to distribute workload. We have the elastic scaling to automatically adjust resources based on demand. So these have been already discussed. So which are the AWS services we have for scaling? So we have Amazon EC2 for scalable compute capacity. We have Amazon RDS for scalable relational databases. We have Amazon S3 for scalable storage and data retrieval. So coming to initially the EC2. So EC2 instances can be horizontally scaled by adding or removing instances based on demand. Or we have the concept of auto scaling groups, where like AWS provides auto scaling groups allowing you to set policies to automatically adjust the number of EC2 instances. So scaling policies can be triggered by metrics like CPU utilization or network traffic. Also we have the option of manual scaling as well. So you can also manually adjust the number of instances based on anticipated changes in demand or specific schedules. So in terms of vertical scaling for EC2 instances, it can be vertically scaled by modifying the instance type to increase or decrease resources. So elastic load balancing is also there for vertical scaling. So ELB can distribute traffic across multiple EC2 instances, ensuring even resource utilization. So when scaling vertically, instances with increased resources can be seamlessly added to the ELB pool. So we have the concept of flexible resource configuration. So AMI, which we saw as Amazon Machine Images previously in our EC2 session, we can create custom EMIs with specific configurations, so enabling rapid deployment of instances with predefined settings. Next, we have the instance types. AWS offers variety of instance types optimized for different workloads, allowing you to choose instances with the right balance of CPU, memory, and storage. So in case of RDS, which is the relational database service, in terms of horizontal scaling, we have the concept of RAID replicas. So RDS supports the creation of RAID replicas for read intensive workloads. So these replicas help distribute read queries, improving the overall database performance. So we also have the auto scaling for Aurora. So Amazon Aurora, a MySQL and PostgreSQL compatible database engine, supports automatic scaling based on actual database load. So it adjusts the number of Aurora replicas to handle varying workloads. So in terms of vertical scaling, we have the option of instance modifications, where RDS instances can be vertically scaled by modifying the instance class to increase or decrease compute and memory resources. So in terms of storage scaling, we can dynamically scale storage capacity to accommodate the growing data requirements. So we also have these automated backups and snapshots in RDS. So backup scaling can also be done. So RDS, it provides a cool feature of automated backups, so allowing us to recover our database at any point in time. So this ensures data integrity and provides a scalable backup solution. Also, we have the snapshot scaling capability. So we can create manual snapshots that allow us to capture a point in time copy. Point in time means the snapshot as it was in that point of time. So of our database, providing flexibility in scaling and recovery. Coming to our S3 for scalable storage, we have object storage. So S3, as we already know, it's designed for the scalability of object storage. So it automatically scales to accommodate the virtually unlimited amounts of data, we can say. So next is, already we know the buckets. So you can create multiple S3 buckets to organize and scale your storage requirements based on different projects or departments. In case of performance and durability, so we have this multi-AZ data replication. So S3 automatically replicates data across multiple availability zones, ensuring durability and availability. So this design allows for scalability while maintaining data integrity. Next we have built-in redundancy. So S3 provides multiple storage classes with varying levels of redundancy, allowing you to choose the right balance of durability and cost for your specific use case. It also supports the data transfer acceleration. So AWS S3 data transfer acceleration, it's a scalable and fast way to transfer files to and from S3 using the CloudFront Global Content Delivery Network. So this accelerates data transfer, making it more suitable for large scale distribution and content delivery. So in summary, we can say that scaling in AWS services such as EC2, RDS and S3 involves both horizontal and vertical scaling strategies. So whether adjusting number of instances and replicas or modifying instance types. So AWS provides a range of tools and features to scale resources dynamically, ensuring that our infrastructure can efficiently handle changes in demand while maintaining very optimal performance and cost effectiveness. So, a couple of best practices for high availability in AWS. So, we need to do, first thing is regularly monitor system health and performance. Already, it's always good practice to have an observability team if you are maintaining some DevOps practices, because having a designated team can help you recover faster in case of any issues. So next is design for failure and expect occasional outages. So no system is perfect in this world, as they say. Always, uh, like in hindsight, or like you should anticipate failure always. You should design the systems for failure, because you never know what hits at what time and how much customer requests the system can handle. So we can do some internal chaos engineering, and we can expect occasional outages in our systems. Next is we need to automate recovery process to minimize downtime. So the infrastructure that needs to be set up in case of any downtime, it should involve automation tools such as Terraform for infrastructure, and Packer, for example. Packer is a tool by HashiCorp which will help create a golden image for multiple cloud providers. So it's always good that you have this sophisticated DevOps tools handy, so there's no much revenue loss in terms of customers. So there are some architectural patterns that we need to understand for high availability in AWS. First is active active, which means multiple instances simultaneously handle requests. Next we have the active passive, which is primary instance handles request, secondary instance acts as backup. In case the primary instance doesn't handle one, then the request goes to the secondary instance. Next is the master slave. So here the primary instance performs read and write operations. So secondary instances replicate data. So the majority of the workload is taken by the primary instance, and just secondary operations or day 2 operations, as we can see, it will be performed by the secondary instance. So next is we need to understand the AWS global infrastructure for high availability. So high availability is not possible without having a global infrastructure. So if you have all the data centers in a single country, you can't say that your systems are highly available, because it's not spanning across the globe, right? So, but with the power of AWS, we have this concept of regions, as we saw already. So geographically isolated locations with multiple availability zones. So I think multiple countries AWS has it. Almost all major country in the world, AWS has a region. So that availability is taken care of. Next is availability zones. So within regions we have this physically separate data centers within a region. Next we have the edge locations, points of presence for content delivery and low latency access. So edge locations are also globally present in all major countries. So mostly these are suitable for streaming of content based services, for example Netflix, Amazon Prime Video. So people staying near that region can leverage this, where they can quickly access that content. So edge locations make that possible. Next, we should see the high availability and scaling in AWS Lambda. So Lambda is a serverless computing platform for running code without provisioning or managing servers. So here companies just need to worry about the business logic and whatever the underlying infrastructure. Serverless means you are not managing the server, but there is a server which is running on top of it. So it's just a buzzword of the industry that you are not managing the servers with your own hands. So you just need to worry about the business logic and just run the code in those managed platform, and everything is taken care of the application. So it automatically scales based on incoming requests and concurrent executions. So incoming requests, we can say in Lambda, refer to events or triggers that initiate the execution of a Lambda function. So these events can come from various AWS services or external sources such as API Gateway, S3, DynamoDB, or any other AWS service. For example, like if you configure an API Gateway to trigger a Lambda function upon receiving an HTTP request, each HTTP request is considered as an incoming request. So similarly, if a new object is uploaded to an S3 bucket configured to trigger a Lambda function, that event serves as an incoming request. So coming to concurrent executions, so in AWS Lambda they refer to the number of instances of a Lambda function that are running simultaneously. So Lambda functions can be executed concurrently in response to multiple incoming requests depending on the workload and the configuration. So if a Lambda function is configured to process S3 events in our case, let's see, and there are simultaneous uploads of multiple objects to the S3 bucket. So the Lambda function, what it does, it may experience concurrent executions. So each execution handles a specific event independently, allowing the function to scale horizontally to manage the workload efficiently. So it also supports event-driven architectures for high availability and scalability. Means Actually, it's one of the key strengths of this serverless computing. So Lambda is very particularly well suited for this. For example, we can have multiple event sources. So there can be some drivers triggers. So AWS Lambda can be triggered by a wide range of event sources, both from AWS and external. So this may include like from S3 or DynamoDB, Kinesis, SNS, SQS, and many more. Also, we have the possibility of creating custom events. So it allows us to create custom event sources using an SDK or an API gateway. So this flexibility allows developers to build event-driven applications tailored to specific requirements. Also, it has automatic scaling based on like dynamic resource allocation is there, and another one is concurrent execution is also there. So Lambda functions, they also follow the event handler paradigm. So we'll understand when you are dealing with the AWS Lambda session. So for now, understand that it's just in event driven model, and also it has integrations with other AWS services, and also it has event monitoring and logging with CloudWatch as well. So high availability in RDS, we have already seen how it works. So multi-agent deployments is there for automatic failure and data replication. So read replicas for scaling read heavy workloads, and there are automated backups and database snapshots for data protection. So again, S3 also high availability we need to discuss. So it has a distributed storage system with 99.999999999%, which is 9 nines durability, which is very awesome. Then data is automatically replicated across multiple availability zones. So high availability is taken care here as well, with data being resided in more than one availability zone at a given point of time. Then it supports versioning and cross-region replication for enhanced availability. So versioning is also there for a single object. You can have multiple versions of it, and then do a cross-region replication. So we can replicate the same data in two alternate regions as well. So this is about the availability in S3. So HA in uh, actually availability is also called as HA. In layman terms, if we are dealing with cloud in a day-to-day basis. So in terms of elastic load balancer, it automatically distributes incoming traffic across multiple instances. Again, it monitors instance health and redirects traffic in case of failures. So it will transfer the request to a healthier instance in case the receiving instance is in unhealthy state due to some resource constraints. Then it supports SSL termination and sticky sessions for enhanced availability. Next we have the AWS auto scaling groups. So logical grouping of EC2 instances for automatic scaling. So we need to we can logically group if that EC2 instances group is serving a production or a QA or testing environment, or it is serving a specific type of application, then we can logically segregate them for auto scaling. Then it has the concept of policies that define scaling triggers and actions. Then it supports scaling based on CPU utilization, network traffic, or custom metrics. So you can scale based on the CPU utilization, for example, or the machine type or the instance type. Any kind of configuration you can do the auto scaling. So there are some challenges for availability and scaling. So first thing is ensuring consistent data synchronization and replication. So there are some couple of challenges here, like maintaining consistency across multiple replicas or nodes in a high availability setup can be very challenging. Ensure that all replicas have the latest and accurate data is very crucial to prevent discrepancies and data corruption. But there is some solution. So implementing robust synchronization mechanisms such as two-phase commit protocols or distributed consensus algorithms can help maintain data consistency across multiple nodes. Also, there are some latency and network delays, conflict resolution. So there are some partitioning and sharding options, dynamic scaling challenges, data volume and throughput challenges are there. So handling sudden spikes in traffic or workload is also one challenge. So managing costs and optimizing resource allocation is another challenge actually. So we can leverage monitoring and alerting for high availability. So we can utilize CloudWatch for monitoring system metrics and logs. We can set up alarms to trigger notifications for critical events or thresholds with the help of Amazon SNS service. Also, we can implement automated remediation actions based on alerts. So we can configure alerts with Slack or any communication tool you want for easier resolution. So CloudWatch is actually one good service which mostly I think it supports almost every service in AWS. So next is disaster recovery and high availability in AWS. So we can create backups and snapshots for data protection. We can implement cross-region replication for disaster recovery. And then we can test and validate disaster recovery plans periodically. For example, we can have our SRE teams always test this by injecting some fault in the available systems and validate our fault tolerance plans. So the conclusion is the high availability and scaling are very crucial for the modern cloud-based applications. So AWS provides a wide range of services and tools to achieve high availability and scaling. So implementing best practices and architectural patterns in AWS, it ensures very robust and reliable systems. So before moving into the conclusion, I'll just go to the hands-on now. So I'm in my cloud environment already, and we'll see first what a launch template is. So there are a good way to streamline, simplify and standardize the instance launches. So I'll go to EC2, and in the left side we can see under the instance types, and here we have the launch templates. So we'll first create our launch template. So it just gives us an area. It says EC2 launch template, streamline, simplify and standard instance launches. It says use launch templates to automate instance launches, simplify permission policies, and enforce best practice across your organization. So the benefits are streamlined provisioning. It minimizes steps to provision instances with EC2 autoscaling. Updates to a launch template can be automatically passed into a autoscaling group. Also, it simplifies permissions and ensures governance. So we'll proceed with our steps. So I'll hit cross create launch template. So I'll give it has this L my first launch template, and template version description. We can give anything regarding the scenario. So a test template is what I will give. So we don't need any auto scaling guidance, so we'll do everything from the scratch. There's a provision of template tags. So you can add the tag as, for example, which environment that particular template belongs to. I can, in case of IT environments, you can just use an environment tag and just enter the value as prod, which is short for production. So observe here we have the source template option here. So if we hit it, it says you can optionally specify a source template if you would like to create a template from another existing template. So if you have already one built for your team earlier and you want to make some smaller modifications for it, then you can use that as well. So there's a provision. So since there aren't any, so we don't have any templates under our name. So next we'll go to the launch template contents. We have the application and OS images, which is short for AMI. So we have all the different options. Like an AMI is a template that contains the software configuration. It has all the OS, application server and other related specifications. So I have a bunch of OS to choose from, which is the Amazon Linux, Mac OS, Ubuntu, which is from Canonical. Windows we have Microsoft, Red Hat, SUSE Linux, Debian. So these are most popular OS are available. So it's always better and advisable that you choose a operating system that you're familiar with and the scripts that you're going to run. So you'll actually have your own automation scripts ready, right, for the respective EC2 instances. So it's always be ready that it should be very platform compliant. So for now I'll choose the Amazon Linux. We'll choose the latest version here, which is 2023. Next here in this box we have the instance type. So what we'll do is under the list of instances that we have, we'll just go ahead with a T2 small. So whichever instance that you spin up with this launch template, it will go with the EC2 instant type of T2.small with this template, and we'll use all generations here. So this keeper, you already know that this is to SSH into our instances. So since we don't have any keeper, so I'll leave it as it is. So next, network settings, we will include a network. Uh, if you are running a multi availability zone deployment, then you don't need to have this. But for just for the testing purpose, I am selecting a subnet which is residing in availability zone West East 1C. So we'll select an existing security group. so which is the default security group. And if we type advanced network configuration, you have more fine-grained control about how you can assign the primary IP and the secondary IPs. So if you want to auto assign a public IP, I'll make it enable so that it will get a public IP. Then we have the different IPv4 prefixes and IPv6 prefixes. We have the delete on termination, network card index, assign primary IPv6. Yeah, like it gives a more fine-grained intro. So also we have the provision of adding another network interface. Next, coming to the storage volumes, we have the provision of adding EBS volumes as well. So we'll just see the volume configuration here. We have a default volume 1 which has a size of 8 gigabytes, GP3 volume type, IOPS of 3000, encryption, it's not encrypted, delete on termination is yes, throughput is 125. So we'll leave this default as it is with the selected one. We'll add a resource tag for this. So we'll enter environment and value will be prod here again. So you can select the different resource types which can get attached to this key value type. So we have the volume already, and I'll select network interfaces as well since we have selected the subnet. So next we have the advanced details. So you need not know each and every part of the advanced configuration. For exam point of view, just IAM instance profile and hostname type and instance auto recovery and shutdown behavior will suffice. So if I add some any custom one, if you have already existing instance profile, then specifically that will act upon the launched instance as well. Also we have the hostname types, which is IP name and resource name. We have the instance auto recovery options, which is default and disabled. Also we have the shutdown behavior. So if you shut down the EC2 instances, they will stop or terminate. So we have the stop hibernate behavior. Hibernate means go on to a dormant stage. So it also has the enable and disable options. So keeping all the things as default, I'll just go ahead and create the launch template. So we have successfully created a launch template. So what we'll do is we'll just go ahead and create a instance with this launch template. So I'll go to instances. I'll go to launch instance. So under the launch template section, under actions, we have launch instance from a template. So when we hit that, we come to the source template here. So it says the version is 1, which is default, and the source template says my first launch template since we have created it just now. So we also have the sample details of it. We have the software image AMI, we have the virtual server type, we have the firewall which is default, we have the storage volumes. So how many instances I want. So how much simple it is let's say I want to launch 5 instances. So I just go ahead and launch the instance. So we'll proceed without a key pair. That's what it asks. Go ahead and launch again. Successfully initiated launch of instances. So we'll go to EC2 back again, instances running. So we'll just load it. So instance state is pending. We can see how fast the automation is there here. So with a single launch template, we are able to launch 5 identical EC2 instances. And so instead of going one by one each and every time, so this will enable us to scale the application very fast. So you can see all the instance types are T2 small and the instance are in running state. And also the availability zone they are running is in US East 1C. So next we have under EC2 we have this, at the end we have the auto scaling groups. So how this works, auto scaling groups are collections of Amazon EC2 instances that enable automatic scaling and fleet management features. So these features help you maintain the healthy and availability of applications. So this is how it works: the minimum size, the scale out as needed, the desired capacity. So it works on the required capacity basis. The benefits and features are again fault tolerance, availability and cost management. We have the related services. We can use Amazon EC2, CloudWatch or load balancing along with this. So we'll first create our auto scaling group. The name can be like my first AG, which is auto scaling group. So launch template, I'll select the my first launch template that we already created. Version will remain the same, which is default one, and I'll hit the instance type will also remain, so it will be taken from the launch template itself. So I'll hit next. So here we also have the instance type requirements. So since it's already populated from the template, you can override the launch template as well. So if I type here, you can also customize more granularly about the vCPUs, the memory, etc. So here I'll not go and change anything. So the purchase options can also be played around, where the distribution means on demand or spot. Spot instances are nothing but if your application is not very critical, like it should not be highly available at our time, all time, then you can modify the percentages for on demand and spot as well. So it also says that to run fault tolerant workloads at low cost, define a percent of instances that will be spot instances. So if you are looking to afford that low cost fault tolerance operations, then you can go ahead with this. And then allocation state is always be lowest price. Then VPC I have selected default. Availability zones will select the USD is to 1A. You can select multiple as well. We'll select 2. I'll hit next. So I also have the option of attaching it to load balancer. So since we don't have any load balancer, I'll just select with no load balancer. Also VPC lattice also I'll not select anything. So health checks will be always enabled, and the period will be between each health check will be 300 seconds. So I'll enable the monitoring here. I'll enable group metrics. Hit next. So the unit will be number of instances. So I'll give the desired capacity as 5 here. So minimum desired capacity will be 1 because one instance will always be available and it can go up to 5. So we'll also let it be 5, I think, for testing purposes. So automatic scaling is optional. So I'll just ignore that for now. So there are some replacement behavior depending on the availability requirements. First is the mixed behavior, which is no policy. It says for rebalancing events, new instances will launch before terminating others. Here prioritize availability. Next is the control cost, and next is the flexible. So let's go with mixed behavior. I'll hit next. I will not add any notifications. So if you want to send notifications to SNS topics whenever EC2 autoscaling launches or terminates the EC2 instances in your autoscale group. So we'll ignore for now. So we'll just create a tag. I'll just say production prod. Hit next. So yeah, it will so at the last step it will tell us to review the page. So first is the launch template, next is the network, the instance type since we have ignored, and go with the launch template configuration. Next we have the instance purchase options. We have selected 100% on demand. We have the allocation strategies, which is lowest price. No load balancing is given. So VPC lattice integration we have ignored. Health checks we have took as EC2 type, and grace period we have given the default as 300. So we have enabled the monitoring here with CloudWatch. So desired capacity is 5 for us. The minimum is 1, means one EC2 instance should be at minimum, and 5 is the maximum. So there is no maintenance policy. And next we have added the tag. So we'll go ahead and create the auto scaling group. So it says the max value in VPU CPU count cannot be 0. So just go ahead and edit the vCPU here. I just give vCPU as 2, maximum would be 4. Memory I'll give as 2 GB, and here you can give as 8 GB. I think now it should sort out. So again, once again we'll do. So it says auto scaling group could not be created. So yeah, it was a technical glitch. Now you can see our first launch template is created. Auto scaling group is created successfully. So it says updating capacity. We'll hit refresh couple of times. So you can see the most all the details here. Yeah, this was all about the hands-on session. So we created a launch template, and also with the launch template we had created a auto scaling group here. So we'll move back to the slides. So yeah, this is about the conclusion. As we already discussed, availability and scaling are crucial for modern cloud-based applications. AWS provides a wide range of services and tools to achieve high availability and scaling. So implementing best practices and architectural patterns in AWS ensures robust and reliable systems. So we understood what high availability and scaling in AWS is, and saw a small hands-on session and how it helps enterprises across the globe scale accordingly to their needs. So in the next session we'll see what is serverless computing and what AWS Lambda is. And also we'll do a small hands-on session. So hope this session was useful, and see you in the next session. Thank you.